Mr. Gibson has been involved with highway and pavement engineers for nearly 40 years. He's been involved in construction, design, research, and training. For the last 10 years, he's been a pavement manager for the Regional Transportation of Washoe County, which is an MPO with 3 member agencies. He is responsible for developing an $18 million annual program for pavement preservation program, and he is directly in charge of a $6 million annual preventive maintenance program. Along with his keen interest of pavement engineering, he has an abiding interest in developing safer and more complete streets for better community. Thank you. Welcome, Mr. Scott.
Thank you all for having me today. Again, my name is Scott Gibson, and I am from Reno, Nevada. Washoe County is our local county. I work for an MPO. We're called the Regional Transportation Commission, and we have 3 member agencies, which are the cities of Reno, Sparks, and the county of Washoe. We do 3 things as an MPO. We are the long-range, we developed a long-range transportation plan. We run the bus system, and unusually for an MBO, we have an engineering and construction division to where we actually manage and build the arterial and major collector roadways, the regional level roads in our area, which are essentially roads with greater than 5,000 ADT. Oh, also, and I put our Tesla Gigafactory thing on there. That's one of the big things that the whole world kind of turned and looked and said, hey, what's going on in Reno? That they're building a Tesla Gigafactory. So we're very proud of that as one of our local development things. We're also unusual, or were unusual. In 2002, our voters not once but twice voted by initiative to index our fuel tax to inflation to pay for road and pavement improvements. And I'm happy to see that a lot of the states have finally broken down, and their legislatures have also been passing fuel tax, because our federal friends aren't, the Congress is not, that's just such a non-starter in Congress to provide sufficient funding for our roadways improvements. But for us, it's kind of interesting. We index it to, the first time we did it, we indexed it to the consumer price index, which was flat during the early 2000s while construction inflation was going through the roof. And then most recently, we indexed it to the producer price index, which more closely parallels construction inflation, which keeps our funding levels adequate. And we not only index our local county fuel tax, we index the state tax, which hasn't been raised for 20 years or so, and we keep that chunk. We index the federal fuel tax, and we keep that, which hasn't been raised since 1992 and has about 30% of its buying power. And we also index the federal diesel fuel tax for all the diesel that's sold in our county, which hasn't been raised since 1982, and is the reason we have to build roads 5 feet thick on our interstates. And we also keep that as well. So we're very fortunate in that we have a sufficient funding stream as well. Our local roadways, in terms of our local network, excluding interstate roads, we have a couple interstates that kind of make an X, a north-south and an east-west. Interstate 80 runs through our community. But the red on the first pie chart over there is the network that I'm responsible for, our 1,500 lane-mile regional roads. And then the rest are the other 70% are local residential roads that each of our cities have, and they have a tax increment that kind of takes care of that. And when you look at the trips that occur on each one of those, about 42% of the trips in our community are on those 2 interstates, and about 50% are on our network, and about 8% of the trips are on those local roads. Although lots of people like to say, every trip starts on a local road, so that's a concern for us as well. On our pavement preservation program, when we developed this system, I'll also say I'm in a very fortunate position in that I don't own any of these roads. They all belong to the communities, and their maintenance departments are responsible for the regular conventional maintenance for them. So I don't really have any assets, but again, I manage this tax increment that goes to, we hire the consultants that reconstruct these roadways and oversee the construction in-house ourselves, and then turn them over to our local agencies. But one of the things we had to, when we were developing our program, we had to bring all these agencies together and agree on some things that we call integrated elements. And so each one of our agencies has Micropaver as their pavement management system, and each year they submit a list of aspects of their pavement management system that we use to make decisions on prioritizing what roadways are selected. That's blind to jurisdiction, so it has to benefit, and we'll go through the priorities here a bit, but that PCI can't be more than 3 years old, and that's one of the best aspects of this, because it makes sure that we have good, current, valid data to make decisions on between our agencies as well. And then we all had to come to an agreement on what the regional road categories were and what treatments each of our agencies were comfortable with having placed on their streets. And our tools were slurry seals and microsurfacing, thin overlays, and patching's pretty conventional stuff. And so in terms of distributing and prioritizing what work happens, roads with a PCI less than 50 are eligible for rehabilitation and reconstruction, and then we rank those by ADT. And ones that are with the higher traffic get the first priority in terms of getting funded, and you keep going down that list until you run out of money. And if the first road was in the city of Reno and they had sewer work or something, that meant that they couldn't do that road that year, and the next road was in the city of Sparks, the money would go to the city of Sparks, for example. So again, being blind to jurisdiction. And so the title of this presentation was Decision Making Based on Data, and so I'm going to go through a lot of the data sources that we acquire here. And then we rank the rehab is at different levels. And then preventive maintenance is, most of our roads, our network is in good to very good condition. And so we're kind of in preventive maintenance mode. And to qualify for that, it's 56 to 100, and structural distress less than 5%. And then we have a corrective category that's kind of a catch-all, because there's some low ADT roads that, or lower ADT roads that may never be captured, that we kind of set aside a certain percentage of funding for, so that we can get those in the package, and kind of fills in those gaps between the rehab reconstructs and the preventive maintenance stuff. So in terms of decisions that need to be made, because we're the MPO, we have to have good data on the long range, from our long-range transportation plan, and we work with our planning agencies and such to figure out what our long-range growth needs are going to be, what kind of capacity improvements we're going to have, and then we look at our pavement infrastructure to see what our demands are going to be for funding needs in the future. And that's kind of how we came up with that. That drove our success in passing those fuel tax initiatives, because our long-range needs were out, $4 to $5 billion over the 30-year planning horizon that we developed for our long-range transportation plan. And those costs come directly out of our pavement management system and how we do this stuff. And then our current program of projects, as I said, we use that to prioritize things. And then we also use this data for continuous improvements, how to do it. We look at the performance of these things and figure out how to do it better, faster, and more cost effectively. And so in terms of data sources, we have a lot of old experienced engineers with a lot of institutional knowledge, and we take full advantage of them. We also have then the pavement management data from the pavement management systems and PCI. And then we have an ongoing research contract, 2 of them actually, with our local university, the University of Nevada at Reno, which is home to the Western Region Super Pave Center. And so we have a $150,000 biannual contract for pavement research. And then they also have a traffic engineering department, and we use them for getting data on managing capacity and traffic signal optimization and those types of things. And we also use national studies and participate in organizations like the National Pavement Preservation Partnerships and TRB and such, and try and implement those kind of data. And then we also do a lot of public outreach and use what our community feels. We listen a lot to our community and take seriously their perceptions of what our community, what they want our community to look like long range as we grow. And one of the things that we've started doing recently are corridor studies in our long range transportation plan, in which we look at our major arterial corridors, which have, for example, our Virginia Street, which is our old traditional main street through our community, has like 28 pavement management segments in the pavement management system. But that corridor goes through the university, through a new thriving business district, through our casino district, and so there's a lot of different needs through different neighborhoods on that, and we have a corridor plan that identifies, and there's been a ton of public outreach and community meetings associated with that, and it gives us a plan of what that corridor needs to look like in the future when the pavement demands bring us, get to be such that a project happens there. Does it need wider sidewalks? What's the inadequacies from the ADA perspective and that kind of thing? So this corridor planning tool has been a great benefit in kind of paving the way for our public outreach when we have projects come up and getting them to move forward. This is a type 3 microsurface. This is kind of our workhorse in terms of how we maintain we do about 200 lane miles of this stuff a year. And again, like I said, we're kind of in preventive maintenance mode in terms of our pavement preservation tools. And again, here's your basic pavement preservation curve, and the idea with preventive maintenance is that you do these small, inexpensive treatments, and that you push that red line out from the purple line. And the whole idea behind all of these is to extend the pavement life overall of your network and your system. So that's what it looks like in theory, and as I said, we take advantage of our old engineers, and this is kind of what it looks like in real life. We have a county engineer who's been doing this stuff for since the early 90s, and he was a micropaver power user, and so he had to come up with his own family of curves, and so back in the 90s he developed a set of our family curves for his collectors, residential and arterial roadways. And in 1993, this was the performance curve for his arterial roadways. And then he got very aggressive on doing pavement preservation, primarily chip seals, but also evaluating new materials and that kind of stuff. A guy named Doug Olson, who was with Intermountain Slurry Seal at the time, was always going, hey, we've got this new stuff called microsurfacing. He'd go, yeah, bring it on. We'll try it on this road over here. So he was always very aggressive at implementing all of these things. And so after, and then we took over the maintenance of many of their roadways. And I'm going, you know, Greg, your curve is showing this road to be like a 50 and it's like an 80. So can you go back and check on that? And so he hadn't done this for 20 years. And after 20 years, he went back, and this was the performance curve for his arterials about 20 years later. And so after 20 years of good pavement preservation practices, he'd essentially doubled the performance life of his network, which kind of gave us the model of we should be doing what this guy's been doing for a long time. And we sort of built our system around that, and it's the kind of standard pavement management philosophy that you'll see espoused at conferences like this. And but having his information gives you really good confidence in moving forward with those kind of things. We also, and for my purposes, I have a Street Saver, which is a pavement management product. Again, our agencies use Micropaver. They've been using it for 25 or 30 years. Nobody there wants to change, but I took Street Saver, so I consolidate all of their data so I can make some decisions about the network as a whole, independent of the individual agency boundaries. And this is a really cool tool. This is again, the dashboard that gives you remaining life and breaks your network down into arterials and collectors and residentials, and gives you the PCIs associated with those. And the other cool thing about it is that it's web-based. And so in our research with the University of Nevada, Reno, their graduate students can go in here and look anytime and see and pull off data to use in their analysis of some long-term performance projects that we have going on. So just to talk about a couple of those things, some of our research results that I think are significant. There's been talk about optimal timing for preventive maintenance treatments and when is the best time to apply these things. Well, this is an NCHRP report that was done back in the early mid-2000s or so. So this has been out there for a while, and we applied that, and I gave it to the university and said, well, can we take a look at some of the data that we have? And they got in and pulled out some, did a two-phase project, first to determine what's the optimal timing for putting down a slurry seal. And then the second thing, what's the most optimal time to do a second slurry seal as well. And and so if you look at this initially, the first thing they looked at was that if you put the initial slurry seal on, you get much more of a bit of life extension when you come down to the terminal serviceability of about 2 years. If you wait until like 7 years to put it on, you really get no ultimate benefit out of that. And so we have, and one of the things in terms of slurry seal effectiveness, the effectiveness is that the area under the curve after you applied the slurry seal to the area under the curve of how the road would perform initially. And if you take those, there's some different calculations you can make in terms of benefit and benefit cost ratio. The benefit essentially is kind of the percentage. And one of the striking things we found initially, Dr. Peter Sabali said, well, you know, there might be some age hardening associated with it if you put these treatments on at a different time or wait on that. But there was this really striking spike in terms of benefit if you applied your first slurry seal at 3 years. And the same effect happens for overlays as well, between 3 and 5 years on an overlay. And so looking at this, we're just going, well, man, what is going on with these? What's the mechanism that's happening with these benefits? And we went and looked into some additional benefit type of things, and then we started looking at second slurry seals, and you put the first one on, you know, and it kind of peters out towards the end of the performance life at the terminal serviceability. But when you place that second slurry seal, that's when you really start to see an increase in performance life overall. And here's an example. The red lines are extension in pavement service life in terms of years. And kind of here's how you model that in terms of what it really looks like on the ground, in terms of this being the additional benefit if you put your first slurry on at 3 years and then your second one on at 7 years, which kind of turned out to be the optimum for us. You end up having these two down here in terms of benefit, which is kind of like the percent increase in benefit overall. 88% and 77% at this particular timing. And so this is the way we model our network. We do our first slurry seal at 3 years, and then start our 7-year cycle every year after that in terms of doing our microsurfacings now. And again, the mechanism, after thinking about this, well, why is this working this way? There is an age hardening associated with that when you put an asphalt pavement out there. With asphalt, it's all about the aging. And so it actually gets stiffer and stronger, and you're actually getting a structural increase over that first 3 years. And then when you put that first surface treatment on, you're retarding the aging from that point on at a higher structural capacity level. Anyhow, so we've bought into this philosophy, and that's a decision that we've made based on some of the research data that we've got. Some other things that we're looking at is we've got some long-term performance of new technologies. One of them was Cape Seals. We've been comparing slurry seal capped Cape Seals, slurry seal, which is a chip seal with a slurry seal on top, and then a microsurfacing caps, and we're seeing some stronger performance over time with a microsurfacing cap over the conventional slurry seal caps. And then we're also looking at long-term performance of some green technologies. This is a warm mix asphalt with different percentages of wrap. And you can see we start off up here, and again, they're pulling this out of our pavement management system, and then we apply a slurry seal at our 3-year level, and then we're monitoring the performance of those as we go on. And also some other research on intersection mixes and providing better stability at intersections where there's a lot of stopping movements, especially in areas where we have lots of commercial trucks and that kind of thing around malls and Walmarts and Kmarts and those kind of things. And so my goal right now is, this was how we improved performance over that first 20 years, but there's a lot of stuff reflected in this where we're continuing trying to push those curves out and get additional pavement life out of it. Now I want to switch gears a little bit in some of that public data that we use. We got a new executive director, and I've been very proud of our pavement management system and program. And we got a new executive director, and he was a planner, and he was a transit guy. You say the words pavement infrastructure to him, and his eyes kind of roll back up in his head. And many of you probably experience that with decision makers in your communities and such. But we had, so the first time I was giving a presentation before our board, he looked up and down at our board members and said, "My favorite subject, watching asphalt congeal." And so it kind of I need to work on this guy a little bit. And so we have started doing I'm a cyclist, and so when I look at roads and I look at our pavement network and the work that we do, I see opportunities for bike lanes and that type of thing. And we have been adopting and promoting complete streets policies for many years, and trying to, because we're the MPO and we run the transit system, we're trying to do mode shift and get people on buses and out of cars and reduce the demands for more pavement and lane miles in the future. So organizationally, we kind of have that philosophy, and it aligns with my personal preferences of things. And so when you've got a champion in my position, when I see roads, I see opportunities for bike lanes and stuff. So we've started doing road diets, had started doing road diets, and that's when you take a 4-lane undivided roadway and convert it into a 2-lane roadway with a center turn lane in the middle, and that gives you, with that extra lane, you can take the bike lane out or add bike lanes, take that additional lane and turn it into bike lanes, and it ends up slowing things down. Now the guy in the blue car is controlling the speed, and it works on roadways with about 18,000 a day ADT or less, and 1,500 vehicles per hour on peak areas, improves the pedestrian environment and slows traffic down. So people are loving this kind of stuff. And we also have gotten data so that other UNR project, we had them do long-range studies on before and after on some of our road diet projects. And we're getting like 40% reductions in crashes on these roadways, which is not unusual, and that's from the national safety data. It gives you a safety factor of 30% reduction in crashes if you do these kind of things. And the reason it happens is because you're reducing the conflict points on these roadways so much. And so you go from, and just in the middle of the roadway, you go from 6 conflict points down to 2 conflict points. And so it doesn't matter whether they're inebriated, elderly, full of teenage hormones, there's just less places in space for objects to collide with each other. And so you have these dramatic improvements in safety over these roadways. And the other good part about it is that this is pavement preservation. I'm now getting to broaden the conversation about, I was going to slurry seal this street anyhow. So it's almost gravy to have these dramatic improvements in safety and condition and community improving features through our pavement preservation program. When you do this stuff, you got to do, and we also just narrow lanes and add bike lanes. This is some cases where we do that. And it takes some striping design. We have part of on our annual projects, we have some funding for doing striping design and engineering, and you got to look at lane configurations and signal heads and loop detection. We have a budget for the number of loops that we may need to adjust or realign so that everything works okay. And there's some added maintenance costs because there's more stripes out there, and our local agencies can, act like like you've cut their arms off because I've got to do more stripes now. Tough. It's safer. But, and so we started this project, and again, we had, so our executive director wanted to do, there was some money called this TCSP grant, Transportation, Community and System Preservation Grant, which is, I'm going, man, that sounds like complete streets and pavement preservation. And he was going, so how are we going to get this money? And I said, well, somebody suggested this one corridor needed some transit facilities. And I said, that's slated to be for a road diet. It's a candidate for a road diet in the future, and we were going to slurry seal that one anyhow. And he goes, well, okay, I like that idea, and we got it. So how are we going to do the match? And I go, well, we can use the slurry seal as the match for this program. And we applied for the grant, and we got $1 million, and we used the pavement preservation, the slurry seal program that we're doing anyhow as a match for the $1 million grant. And this is what it ended up looking like before and after. We corrected all kinds of pedestrian improvements and widened the sidewalks and added transit facilities and bulb outs, and there's our slurry seal preserving the pavement on that roadway. So if you leverage this stuff, again, you can get a lot of support for things. And like I say, we do a good job of pavement preservation in our community. The green and blue the green is my network, the blue is our network overall, and then the red is a Bay Area community that I won't name. But again, good roads are significantly cheaper. We're in pavement preservation mode, so I'm in the 25, 30 cents a square foot mode, or $3 a yard, I guess. But that community in red, for them to dig themselves out of their backlog hole, they're in the $10 a square foot or $100 a square foot category for the reconstruction that they have on their network. And so their backlog and the monetary hole that they're in, that they need to dig themselves out of, is significant. And because we have our roadways that are in such good condition, they took my pavement preservation money, which is $18 million a year, and said, can we defer that for 2 years? And well, they didn't really ask me. They said, we're taking your pavement preservation money for 2 years. And but they took it out and they put it into 2 corridors that we had those corridors studied for. One of them was that Virginia Street corridor, and another one was a our old Highway 40, the 4th and Prater corridor, which are enormous and had a lot of needs and, again, needed pavement as well. But they took that pavement preservation money and used that $32 million to leverage a Tiger grant to get an additional $25 million that is going to fund electric buses and BRT and the stations for all of that. And then the pavement preservation money goes to fix the pavements and widen the sidewalks and dramatically improve these entire corridors that have been in our planning program for a while. And so that's a Believe sculpture from Burning Man that we're also the gateway to. So anyhow, again, it provides, so my pavement program is getting to be pretty popular amongst our planning folks these days. And one last thing in terms of data, also to I heard somebody else talking from Billings, Montana on chip seals and roads. If you Google chip seals, you will often come up with a bicycle gloved hand, which is indicating that these crazy people at the DOT have ruined my favorite bicycle route. But John Harvey at the UC Davis at the University of California, and we've recently participated in a study for surface treatment, macro texture, and bicycle ride quality. And so there's some studies out there. This is one for the kind of on state level roads and highways, and there's a new one that's coming out in the next month or so that's more for urban communities. But what kind of gradations you can use for your surface treatments to come up with something that is accommodating to cyclists and road cyclists. And they took, so they did this study and put accelerometers on bicycles and got a lot of data that way and correlated it to laser surface measurements and then inertial profilometers, and then kind of correlated that down to what size sand patch, along with surveys of cyclists to see what kind of sand patch diameter would be acceptable for that. For those of you who have communities with lots of recreational riders that you need to keep happy while also doing your pavement preservation program. And so again, this is part of our participation in our urban surface study. I'm told we saved their bacon because we had a lot of good gradation data on all of our surface treatments, and the other communities they studied didn't have as much information. So again, there's all kinds of data that we use to make decisions on our pavement preservation that isn't necessarily related to pavement. But it's critical to have that good quality information to make good decisions about improving things and be able to make your case in the long run. And then also it's, make your pavement program part of a bigger conversation about safety and complete streets and better communities and those kind of things, and you'll get a lot more support from your community leaders and other decision makers. And with that, questions?
Scott, one of the questions I had was, because you really don't own any of these roads, you asked for the PCI. Do you have a process that in the approval where, let's say, you have some say, or do you need to approve the treatment, or do you go through that process?
We have a pavement preservation subcommittee that's made up of each of the public works folks from each of our agencies, and then our board is made up of city council members and county commissioners of each of the local agencies. And so they have actually approved that pavement preservation process, that prioritization process for how that money gets distributed. And it's signed by all of their public works directors at one point in time. And again, the money comes to us, and so we're kind of the cash cow. And so that gives us, it's a very good, for those of other you who are in MPOs and that type of thing, that's a really good model for the MPO, because normally the MPO is just a pass-through. We qualify for, the community for the federal funding that comes down through the state and that type of thing. But because of this index fuel tax and having our own revenue stream, anyhow, it's a really effective way in terms of raising the bar all the way across the pavement network in the community.
Hey, Scott. I had a question in terms of, you've pretty much gotten your network into a preservable capacity. So
Yes.
almost all of you're managing basically or a lot of this on the aggregated all the distresses through the PCI.
Yes.
Are you mostly dealing with environmental or any benefit potentially of looking at your bus routes and your truck routes, which might have more of a wheel path or load related distresses versus your less loaded roads?
Again, it's all, as I like to say, we've got roads that we've done stuff to that we know that we shouldn't have done stuff to, that we did a double micro, for example, on, and it was a PCI of 45 or so. And in our heads, we know what that road looks like underneath there, but we've done it anyhow. And we have to deal with, and we have city engineers who know that, they want to reconstruct that road in the worst way. But as you come around, until it shows up in the PCI as falling below a PCI of 50, sorry, it's a preventive maintenance or a corrective maintenance, depending again what the ADT on. That we have a vehicle for making the case for certain roadways, but all of our routes, all of our bus routes are automatically regional roads because it's the buses that hit them the hardest, and they tend to show up and and we design them appropriately. And our agencies, we kind of follow their guidelines, and they've got standard structural sections. And those standard structural sections are very robust and have been very helpful because it gives you enough pavement to work with in terms of mill and fill and that type of thing. But they're also, with the preservation scheme that we've been using, they continue to last. They perform very well also.
So you're picking those differences up not through your condition survey and your decision trees, but through other means, the differences between the environmentally failing and the load related. Sounds like you're picking that up with other engineering means.
Yes, yeah. We don't break it out specifically. It's strictly by that PCI. And we've got some just particular material characteristics where raveling some of our pits, they are susceptible to raveling. And we've had roadways that you put them down and on a 4-inch pavement, and if you don't do anything to it, it will ravel through depending on what percentage of the portion of what pit they used from the top down. But you put a slurry seal on it and it fixes that problem, and structurally they're really stout. So that was when we started doing slurry seals everywhere, that problem has gone away. Our agencies had a specific category of raveling because it was such a unique distress that was causing so much problems for them.
If there's no more questions, we're going to consider this session wrapped. You guys can go enjoy your break.
Thank you.
Thank you.